Okay, so get this. We're talking about the future, like way out there. A future where we're mining comets, those things, and building bases on the moon, like actual bases. We might even be turning Mars into a second home. I know, crazy, right?
It is pretty. Yep, vast reserves of ice and silicates all just floating out there.
I've never thought about mining Saturn's rings before.
It's pretty wild, right?
Totally wild. And hey, what about the Kuiper Belt? Pluto's old stomping grounds? There's got to be something good out there, right?
Absolutely. The Kuiper Belt is full of dwarf planets and icy bodies. Water ice, nitrogen, methane, you name it, it's probably out there.
Okay, so we've got this cosmic menu of resources. But how do we even get to them? I mean, aren't we talking about insane distances and crazy challenges?
Well, yeah, it's definitely not easy. We're talking about massive distances, communication delays that make your internet look lightning fast.
Uh-huh. Oh no, space lag.
And then there's radiation, extreme temperatures. I mean, working in space is no walk in the park.
It sounds pretty intense.
Yeah.
So how are we tackling these challenges?
Well, we're looking at some pretty radical solutions, like nuclear propulsion systems, for one.
Whoa, nuclear. That sounds serious.
It is, but it has the potential to really cut down travel times. Imagine reaching Mars in weeks instead of months.
Weeks. That'd be amazing. No more packing for a year-long trip.
Right. And then there are autonomous mining robots. Robots working tirelessly on asteroids or comets, extracting resources without needing us to babysit them constantly.
Like little space miners.
Hmm.
That's incredible. AI is really going to change everything about space, huh?
Oh, for sure. AI and robotics are key to making space resource utilization viable.
It's really amazing to think about. And what was that thing you mentioned earlier, ISRU? What does that even stand for?
Oh, yeah, ISRU. It stands for In Situ Resource Utilization.
Okay, that's a mouthful.
Basically, it means using the resources we find on site, to build structures, generate power, even create fuel.
So we're talking about like building a house on Mars, but using Martian bricks.
Exactly.
What?
3D printing habitats using lunar dust, extracting oxygen from Martian rocks. It's all about living off the land, but in space.
It sounds so futuristic, but also kind of practical. Like the ultimate recycling program, but on a cosmic scale.
I like that, the ultimate recycling program.
So where do we even start with all of this?
Well, the moon seems like a pretty good first step.
Makes sense. It's our closest neighbor.
Exactly. It's relatively close to Earth. We've already been there, and we know it has resources we can use.
Oh yeah, all that water ice. I remember reading about that.
Yeah, it's locked away in those permanently shadowed craters.
Crazy how it can stay frozen like that.
It is, isn't it? And that water ice, it's like a Swiss Army knife of resources. You can melt it for drinking water, break it down for oxygen to breathe, and even use the hydrogen for rocket fuel.
Wow, talk about multi-purpose. And what about the regolith? The moon dust, right? You mentioned it being useful too.
Absolutely. Regolith's got elements like silicon, aluminum, titanium. You could be holding a cup made from moon dust someday.
A moon dust cup. I'll take 2.
Yeah.
Seriously though, are there actual construction projects on the moon happening?
More than you might think. The Artemis program, NASA's big project, is all about a sustainable human presence on the moon. And using lunar resources is a huge part of that plan.
I've heard of Artemis. It's pretty ambitious. And what about the Lunar Gateway? How does that fit into the picture?
The Lunar Gateway is going to be a space station orbiting the moon. Think of it as a hub for lunar missions, coordinating everything from resource extraction to science experiments.
It's like a central command for the moon.
Exactly.
So, are there companies already working on lunar resources?
Oh, yeah, definitely. It's not just government agencies anymore. Private companies like Astrobotic and iSpace are making huge strides.
I haven't heard of those.
They're developing some seriously cool tech to navigate the moon, make building materials from regolith, power operations during the long lunar nights.
It's incredible to think about. It's like a whole new space age is dawning. But the moon's not the only player in this game, right? What about Mars?
Ah, Mars, the big dream. It's not just about the resources, it's about the potential for human settlement. Imagine calling Mars home, walking on red sand, seeing 2 moons in the sky.
Wow. Living on another planet. It's hard to even wrap my head around that. Okay, back to reality for a second. What kind of resources are we talking about on Mars? I'm guessing water ice is still important?
Water ice is definitely key, yes. It's there in the polar caps and maybe underground, too. For drinking, growing food, making rocket fuel.
So Mars could be a refueling station for deeper space missions.
Exactly. But it gets even more interesting. Mars has a thin atmosphere, mostly carbon dioxide, and we're developing tech to capture that carbon dioxide to make breathable oxygen and methane.
Wait, methane? Isn't that...
A key component of rocket fuel, you bet.
So we could make rocket fuel on Mars using Martian air.
That's the goal. It would make interplanetary travel so much more feasible.
This is just, wow, it's mind-blowing.
It is pretty amazing.
But Mars is also a scientific goldmine, right? There's the whole question of past life.
You're right. Mars gives us a unique look into the solar system's history, planetary formation, evolution, maybe even evidence of past life.
It's like a whole planet is waiting to tell us its secrets.
It is.
But let's be real, Mars isn't exactly a paradise. Thin atmosphere, radiation, dust storms.
Oh, that challenges are definitely there.
So how do we overcome them?
Well, researchers are already working on solutions. Radiation-shielded habitats, maybe underground, a mix of solar and nuclear power for energy, even autonomous systems to prepare things before humans arrive.
Robots building our Martian homes. It's like something straight out of a movie. But all this talk about mining and building settlements, it makes me wonder, who owns all this stuff? Are there even rules in space?
That's where things get really interesting. We're entering uncharted territory here. As we go further and start using these resources, we have to think about the ethical and legal implications.
Yeah, we don't want a space Wild West.
Exactly. We need clear rules, international agreements to make sure everything's done responsibly and sustainably.
Okay, so those are some big questions. Sounds like I've got a lot more to unpack.
We do, but we'll dive into all that after the break. Stay tuned.
Yeah, it's kind of mind-boggling, all this talk of mining asteroids and building on Mars. But like you said, there's the whole legal side of things. We can't just plant a flag on the moon and call it ours, can we?
Not quite. We do have the Outer Space Treaty. It's from way back in 1967, so it's a good foundation.
1967. Man, that was before we even landed on the moon.
It was, yeah. But the thing is, it was written when governments were the main players in space.
Right, back in the space race days.
Exactly. They didn't really anticipate private companies like SpaceX or Blue Origin, all these companies investing billions in space tech.
It's a whole different ballgame now, that's for sure.
It is. So, yeah, a lot of experts think we need to update the rulebook.
I can see why. I mean, companies need some assurance that they can actually benefit from space resources. But we don't want a space monopoly either. Like, imagine a handful of corporations controlling all the water ice on Mars.
That's a scary thought. We don't want to recreate the inequalities we have on Earth, out in space.
Exactly. It'd be like a cosmic version of the gold rush.
And we all know how that turned out.
So what are some of the ideas out there to prevent that? How do we make sure space resources benefit everyone?
Well, one idea is international agreements specifically for space resource extraction.
Okay, kind of like how we manage fishing rights in international waters.
That's a good analogy. These agreements could set limits on how much is extracted, protect the environment, even establish ways to share revenue from space resources.
So everyone benefits, not just the companies doing the mining.
Exactly.
That sounds a lot fairer. But I still worry about the environmental impact. Mining on Earth can be pretty destructive. We don't want to mess up other planets too.
Absolutely. We can't repeat those mistakes. Sustainable practices are crucial.
What does that look like in space?
Well, it means choosing mining techniques that minimize environmental damage, doing a lot of scientific research first before we start large-scale extraction, and recognizing the value of these celestial bodies beyond just their resources.
It's a huge responsibility.
Yeah.
We're shaping the future of humanity's expansion into space.
No pressure, right?
Right. But let's focus on the positive for a minute. You mentioned international collaboration. Space exploration has a history of bringing people together, hasn't it?
It does. Think about the International Space Station, a truly global effort.
Yeah, it's amazing what we can achieve when we work together. What else can we look forward to?
Well, the tech we're developing for space resource utilization, it's going to have huge impacts back here on Earth, too.
Like what?
Breakthroughs in robotics, material science, energy production, even things like closed-loop life support systems for extreme environments.
So space exploration is going to help us solve problems here at home.
Absolutely.
Okay, last question, and maybe this is a bit far out. Are we really talking about humans mining asteroids and living on Mars, or is this all just science fiction?
Well, remember, what was once science fiction often becomes reality. The internet, smartphones, self-driving cars, they all seemed impossible at one point.
Sure.
The key is investment, research, development, and, of course, global cooperation.
It's a bold vision. But I gotta admit, it's pretty inspiring.
It is, isn't it?
To think we could be exploring the cosmos, pushing the boundaries of knowledge, maybe even building new worlds.
It's an incredible time to be alive, that's for sure. And as we delve deeper into the specifics of space resource utilization, we'll see how this vision can become a reality.
Okay, I'm hooked. Tell me more about the actual technologies, the robots, the 3D printing, all that cool stuff.
Well, let's dive into the world of space mining robots, explore the possibilities of 3D printing with lunar dust, and even consider how we might create rocket fuel using resources found on Mars. It's going to be a wild ride.
All right, so we've talked big picture, we've talked rules. Now I want to get into the nitty-gritty, the cool tech, the stuff that'll make all this space stuff actually happen.
You mean like space mining robots?
Yeah, robots. Tell me about those.
Okay, imagine this. Robots working on asteroids, on the moon, all by themselves. No humans, no joystick, just pure robotic efficiency. Extracting resources all on their own.
So, like, we're not sending astronauts out to do the dangerous mining.
Exactly. The robots become our pioneers, the prospectors of the final frontier.
Makes sense. Less risk for us, more work getting done. But what are these robots actually looking for?
Well, on asteroids, it's often about those platinum group metals.
Platinum. Like the expensive kind.
The very same. They're super valuable here on Earth for electronics, high-tech stuff.
So we're talking space treasure.
In a way, yes. But we can't forget about water ice. That's crucial. And luckily, it's abundant on asteroids, the moon, Mars.
Water. Water everywhere, but not a drop to drink, right?
Not quite. We can drink it, for sure. But more importantly, we can break it down into hydrogen and oxygen.
Ah, right. Air to breathe, fuel for rockets.
Exactly. Imagine refueling your spaceship on Mars with fuel made right there. No need to haul it all the way from Earth.
Base gas stations. I like it.
And it's not just mining. These robots could be our construction workers, too. Building habitats, landing pads, all sorts of stuff.
Robot construction crews on Mars. Okay, now that's cool.
And how about this? 3D printers using lunar regolith. That moon dust we talked about turned into building blocks.
So we could literally 3D print a moon base.
It's not just possible, it's probably the most efficient way to do it. And they're even looking at regolith for radiation shielding.
Smart, considering how much radiation there is out there.
It's one of the biggest challenges, so finding solutions is crucial. But here's something that'll really blow your mind. We're working on making rocket fuel on Mars.
Hold on, wait. Making rocket fuel on Mars?
Yep, using Martian resources.
That sounds like some next-level science.
It is. But the basic idea is pretty simple. You take that Martian air, which is mostly carbon dioxide.
Right. Thin atmosphere, lots of CO2.
Exactly. And there's this process, the Sabatier reaction, that can combine CO2 with hydrogen, the output, methane, and water.
And methane is?
Rocket fuel.
Okay, you've officially blown my mind.
The implications are huge.
Yeah.
Imagine launching missions from Mars without carrying all that fuel from Earth.
It makes space travel so much cheaper, so much more practical.
Exactly. And the best part, all this amazing tech isn't just limited to governments and big corporations anymore.
Oh, so regular people can get involved.
Absolutely. Citizen scientists, entrepreneurs, even artists, everyone's contributing to this space revolution.
I love that. Space exploration for everyone.
It's an exciting time to be alive, wouldn't you say?
You said it. This whole deep dive has been amazing. We've gone from mining asteroids to 3D printing moon bases to making rocket fuel on Mars. It's mind-blowing. The possibilities are endless.
They truly are.
So to all our listeners out there, I'll leave you with this. Imagine we could really tap into the resources of other planets. What would that mean for humanity? Think about it. Explore the resources we've linked. And until next time, keep looking up.